Live again. It's early morning here on Sunday. Just trying to get these parts that I was working on yesterday afternoon finished up. So this video, I basically wanted to go over just actually booting up the machine, because a lot of you guys are looking at getting this machine, and just the simple things that you might be wondering about, I'm going to show you. So basically, to boot up this machine, you just got to turn on the main power, which is on the side of the electrical cabinet here, main switch, and you hear the automatic oiler go. And then you have to boot the controller with this button, because currently the controller is just off. There's nothing happening. It'll boot that, and then lights start flashing and all sorts of things. It takes about 1 minute for the controller to boot up. Now, it's a little bit hard for me to see people's questions. When I do see them, I'll read them out so that other people know what the question was. But if I don't get a chance to answer your question about the mill, just post it in the comments and I'll get back to you a bit later on today. I've got to turn the air on too. The controller's still booting. I will have coffee while we wait. Oh, there we go. Alright. So just got to wait for the air pressure to come up. But in the meantime, since we're not going to do a tool change, the first thing you got to do is turn the light on, because you can't see anything. The light is really good in this machine too. Nice little big LED bar up in there. So the light is on, that's the most important thing to do. And then we're going to reference the machine. So it's already in reference mode. So this is just homing it on the homing switches. So in reference mode, just push the Z up. And I already referenced it before I turn the machine off, so it doesn't have to move much to hit the limit switches. And then I do X and Y. You see these little circle-y reference things pop up. If those don't pop up, you can't use the machine. It'll ask you to reference it first. So do that. Pro tip. And today I'm going to be working on these 50 parts that I machined yesterday afternoon in Op2. So I need to actually change some of the tools in the tool carousel, because it involves some drilling and rigid tapping. So I need to swap out tool 10 and tool 9. So to open the door, push the door button. And I also need to change the vice jaws. So to jog the machine around, you need to come out of reference mode and go to jog mode. And then you can use the key panel here, or you can use the hand wheel to jog it around. And you can change the increments for jogging speed on the controller panel and on the hand wheel here. So a few options, but I'll just drive the table back towards me so I can access it a bit easier. Now what I'll do is I'll just change the soft jaws out quickly. Just going to put this in a stand. The max RPM on the mill, Dan, welcome back, is 9,000 RPM, although it's advertised as 10,000 RPM. So there's another 1,000 RPM that lost somewhere. Lost in translation, potentially. Sorry, this is my liquid breakfast for today. All right, I need to change out the soft jaws and then probe them in. So I'll go through all of that stuff so you guys can really see exactly how to do everything. You could probably consider this some of your training to operate the mill. Need some of that carve smart action. It's the standard jaws out. The other thing I should mention is that if I don't run the mill for about 24 hours, I'll run a spindle warm-up program. But since I ran it, less than 24 hours yesterday, I don't feel there's really any need to run it again. And these are my jaws here. I engraved a little origin point on the fixed jaw, so I'll probe in off that. Need to align these with a little mallet. See how they line up. Almost spot on. Cool. All right. Probe it in. So I might do is put this into the machine. So at the moment, I'm actually on tool 1 and the spindle is empty. And I need to put that hammer in the spindle. But this power drawbar, you can't actuate it manually until you push K11. K11 allows you to actuate the drawbar by the push button. So, pro tip. It's in the manual, but you probably don't want to read that. And I'll put the tool in quick. Got the hammer. Now that's it. Alright, so what we want to do is we're going to measure the work. And there's a few different ways to measure the part or the jaws or whatever. So I'm gonna measure X, Y, and Z for my origin, and it defaults to a global offset G500. So all you need to do is make sure that you choose the correct offset. In my case, it's going to be G54. Otherwise, you're going to have a bad time. And my origin is set on the back side of the fixed jaw. So I need to probe in there and not here. I always just double check that because sometimes I put it in weird locations for unknown reasons. So I like to actually probe in using the hand wheel thingo, because I just get better sort of feel for jogging the machine around rather than this control panel. This is really good for like facing operations or like milling a little bit off stock. You can turn the feed rate down and then just drive. Like if you just want a linear, like a constant feed rate for the length of the X travel, that's really handy. Okay, so I'm gonna probe it in. I'm gonna just give me a moment to fix the camera into the machine. There's no real easy way to do this, unfortunately, but because this is what it's sitting on. It's sitting on this big magic arm clampy thing, and it's a little bit cumbersome. Uno momento. Seems to be working. Okay, see if I can. Oh, almost. Crank some more of these levers. Yeah. Getting there. Well, don't fall. Okay, that should be an okay kind of angle. Alright, so on the control panel I'm set to measure the X. So you can even see here, to jog it around you have to push down this little push button. So change to X, and that's the fastest we can move the machine. And my door, my little camera support thing is probably going to hit the down a little bit, across, and then make sure we zero out the hammer. Now I moved back to this, I was on this mode, now I'm going to a very slow jog mode, and just to get as accurate as possible. And now you just got to set the work offset as 0 on the control panel, which I'll show you on the last one I do. And I'll just do Y, and then I'll do Z. So this is the important part. Don't break the tip of the hammer. You see it all the time. So make sure you back away in the correct direction slowly first. So I'm going to do the Y, which is on the back of the jaw. That's the Y. Set work offset for Y. And then I jog it away in the correct direction. And I come up on Z. Go over to my origin point. Jog it down. Measure the Z height. Okay. Now I'm going to pull this back out of the machine. Okay, so that hammer is now zeroed on the Z axis too. This hammer is great for that kind of thing. And I previously set the work offset on the Y axis, now I want to do the Z axis. Still, G54 stays the same now that we've configured it for 1, and then we just go set work offset. So now we can go back, and we're in the machine coordinate system. We want to go to the work coordinate system, but it's actually in G500 at the moment, so we need to activate the work coordinate system we're going to use, which is G54, and then I'll just verify that I've probed in the right spot. So I've got a little program for that. What I'm going to do is just jog the probe up and out the way, because I don't want to go to the home position with the probe touching the part. So on the control panel here, I can just go jog again and then up on the Z. And then I've got a little program written in the manual, the MDI section of the controller here, which is just going to send the spindle or the table to X and Y0 and G54. So I have to close the doors for that, because I don't have any dodgy door override yet. And then I'll just turn the feed rate down, and it's gonna, when I press cycle start, it's gonna go to X and Y0, and it moves quite fast. You probably might not have seen it. So I just turn the feed rate back up so I can jog it around quick. Crack open the door. And we can see now that I'm at X0 and Y0, and the Z is 64 millimeters above where I probed it in. So I'm going to jog it straight down, close to the part, and it looks, it looks like it's on the corner of the vise. So I always like to just verify that in case I'm not thinking straight when I'm probing or I get distracted, because I've done it more than a few times and it really can ruin your part. So yeah, let me take this arm out of the machine now. because it's not gonna like being in there during milling. Trying to show you guys as much as possible. Yeah. So I haven't seen many comments because I've been looking at the machine, so. Okay. Now, I'm just gonna have a quick coffee and gather my thoughts for the next process. So I probed it in, I'm gonna pull the hammer out. I don't like to leave the hammer in the machine because it gets covered in coolant and chips and stuff, and it's an expensive tool. I wanna keep it in good condition, so pop that out. All right, so the next thing I'm gonna do is I'm gonna change out. I need to put 2 tools in the carousel. I need to put a drill to suit an M3 by 0.5 millimeter thread tap, and then I need to put the thread tap in as well. So let's get stuck into that. Rightio. So at the moment I've got tool 1 in the spindle, which I took out by hand, and I just leave that pocket free for probing stuff. So I need to change tool 3, which is currently a 3mm drill bit, to a drill bit to suit the M3 tap. So what I'm going to do is go TSM on the control panel, and then tool change is highlighted, and then I'm just going to push 3 and then input that, changes color, and then I just push cycle start, and it just will change to tool 3. Cool. And you see it just changed to tool 3 up here. And now I'm going to use the milling machine to measure the length of the tool from the spindle nose to the edge of the tool. So to do that, I need to be in the relative work coordinate system. And I'm going to be flipping between the machine screen, which is the current screen we're on, and the offsets for the tool. So these are the tool offsets, and I'm just going to go to 3 now, because that's the one I'm going to adjust. I'll actually zero it out now, so I don't make any mistakes and enter it in the wrong spot. I always like to double check this part as well. So back to machine, tool 3, open the door. I've got to take this tool out of the spindle. Put in the drill to suit the M3 tap, and I always like to just double check these small drills with some calipers to make sure it's the right diameter, because they all look relatively similar. That's back in the carousel, back in the spindle. Now I'm going to use this, which is a 100mm dial indicated gauge block. I'm going to measure the tool from, I'm just going to measure the length of the tool from the spindle nose, so I'll show you how this. And this is the same procedure if you get the milling machine brand new and you want to configure a tool. This is what I was showing how, this is the way I was showing how to do it. There is like a tool measuring thing in here, but in my opinion, it's confusing. And it's not, I mean, this is the way I used to do it on my old machine too. So yeah, you can do it this way if you want or not. It's up to you. This is just the best way I know of doing it. So I've got the gauge block thingy on the fixed jaw, and I'm in the relative work coordinate system. Now, what you're supposed to do is actually zero the Z on the spindle nose. So that would require me to take out the tool. So imagine there's no tool there. Bloom. It's gone. And then you're gonna actually touch off on the spindle nose, not on the drive dogs for the BT30, and zero it out on this gauge block. And then we're gonna come up with a tool in the spindle, and we're gonna be measuring using the machine the length of this tool from the end of the tool to the spindle nose. So I hope that makes sense. Yeah, so let me just jog that down and get it in the zero position quick, and then we'll enter it into the tool offsets. Okay, so you'll see that little drill is now zeroed on that gauge block, and all this information saves in the machine, and it's very repeatable too. So that's why I didn't measure the spindle nose from the block this time around, because I never change it. So the height of that tool the length of that tool from the spindle nose to the tip is 89.306. So 89.306, I need to go back to offset screen, and then I need to type in 89.306 input, and then that's definitely on tool 3, and I'm definitely on tool 3 there, so happy days. Now I can just jog it up off the gauge block, and then I'll move this out the way for a tool change, and I can't actually remember what pocket I had the tap in, so I'll just check that. So I've just got this pattern set up for the soft jaws. So tool 3 is the drill that I just loaded. That's chamfer operation, that's the ball end mill. Tool 9 is the tap, so I need to change tool 9. So back to this TSM screen. 9, input, cycle start. Just gonna put that tool back in the carousel. Luckily, it's empty. I've sort of been in the habit of removing tools I don't need in the carousel lately. So I'm going to put this tiny little thread tap in there. Focus, man. Yeah, so it's pretty small. Put the gauge block back in place. Come down on that block and zero it. So I'll just go through it once more. So we're on tool 9, tap a 0 on the gauge block. Go back on the screen, make sure we're in the relative coordinate system. That's the length of the tool from the spindle nose. Offset screen, so I've just got to memorize that number, 86361. 86.361. Enter, or input. And then I can hit jog and jog it up. Cool. And we are good to go. Put my little gauge block thing away. Yeah, so we're just going to load some stock into the jaws. And then I need to put the tool path onto the USB stick and transfer it to the machine, which I'll show you guys too. I'll do it in that order. So I can go back from the screen now to the machine workspace, and I'm in tool 9. One other thing I'm going to show you, which is quite handy, is if you go back to offsets, down the bottom here we're in the tool list workspace, and we're going to go to work offset. So where I just probed was this G54 value X, Y, and Z. There's G500, G54, all the way through to G59. And G500 is global, so any value applied to the global columns will affect every other offset. So this is handy if you want to just cut air and verify a toolpath. So you could put a value of Z50. So it means that any of these offsets will then be offset by 50 millimeters on the Z, and you can cut air just to verify a dodgy toolpath or something like that. So I've done that in the past. It's quite handy, and also if you just need to take a little bit off a part, it's also handy. So yeah, I've got G55 in there from yesterday, and I'm actually just going to get rid of it because I don't like to have stuff in the machine that just doesn't need to be there in case I inadvertently activate it. So yeah, just my G54 in there now. Go back to my tool list and back to machine. And I'm going to put some stock in the jaws, so give me a sec. Okay, coffee break. Sorry guys, I'm pretty tired actually. We don't want to hear about that. I might take this moment just to answer any questions that you might have, since I wasn't looking at the screen for the past 30 minutes. Or I'll just do some eyebrow stuff. Okay. So, I'm just going to verify my toolpath stuff. Yeah, Dan, it's just me in the shop today because it's Sunday. There's normally about 10 of us here during the day unless we're out on other jobs. So We've got about 3 guys here trained up to do machining, so yeah, it's not just me in this big old warehouse. So I've got a adaptive thingo with just a roughing end mill just to get rid of that top hat on the component. And then I face it off, boof, like that. And I think I need to adjust some stuff, and then I just got a pattern, a spot drill some holes with chip breaking, and then we just chamfer the edges of the part, give them a nice edge break, and then do the little ball-ended ball mill thingo, and then we tap the holes. And then because the little strings, they pop out of the holes or the tap, and they scratch the surface of the part, so I come along and do another light finishing pass on the part just to give it a nice surface finish. So yeah, we'll give that a run and we'll see how it comes out. So Hamfi says, why don't you side mill the radius when drilling the hole of the loop? Side mill the radius. Oh, this one here. I don't have a radius cutter for it, so this is just my workaround for it. Because quite frankly, I spent a lot of money just setting up everything to this point, so I'm just trying to make do with what I've got for the time being. But yeah, obviously like a radius cutter would just like plow that. Hey Azza, morning mate. You're also up early. Welcome. Yeah, so that's basically the reason why I'm not using a special cutter for that. I know it would save a bit of time, but the little ball mill gives a cool little effect on that I like on there as well, like little ridges and stuff. It's kind of unique in some ways. All right, so I'm gonna post this now to this USB key, and then we'll load it into the machine. And then we're not far off running the part. Plug that in. And I'm gonna just highlight that. And I've actually just got 2 parts in this jaw because this stock I got this time around, I wasn't able to get it cut to the correct size, so I can't fit a part in the middle, which is unfortunate. So I can only do 2 at once. So I'm gonna post-process it with that post-processor that we've modified. I'm gonna call it OP2, and I'm just gonna post it to that USB key. And then it should open in brackets. Yeah, sweet. All right, and I'm just gonna scrub to the bottom of the code. And I've got this little table to door code, so it drives the table to a nice position so I can just unload and load the parts. So I'm gonna copy that. And I'm gonna slap it in just before the M30 at the end. So Hamfi's asking, while building drones, have I thought to use magnesium to save extra weight? I haven't really thought of using that in drones, honestly. I know they use it a lot, and I used to ride a lot of downhill mountain bikes. All right, so that code's in there now. I'll just save it. Pop in the machine. Yeah, and they use magnesium a lot on the suspension components to save weight. But yeah, so I don't really have much experience with magnesium. That's not really much of an excuse not to use it, but I should look into it. So I plugged in the USB. I've gone to Program Manager. And I've got Op1 in the numerical control like storage, and I just hit USB. And I go all the way down to Op2, and I'm gonna go copy, and I'm gonna paste it in the NC if it fits. it fits, which is great. Okay, so Op2 is the one that I want to run. So I'll just verify I've got all the right tools in there. I've got this roughing end mill and tool 5, my chamfering one, a drill, spot drill, ball-ended end mill, and a tap. Yeah, there's the tap. I forgot where the tap was. All right, so we should be good to go. It's loaded in the NC. If it's not in the NC and it's on the USB, I believe you can't just hit auto and then run the cycle again. So you have to keep loading off the USB every time. So that's annoying. All right, so I'm gonna close the doors. The coolant looks about right. There's a button here to turn it on and off. I'll just make sure it's, yeah, so it's aimed in the right spot. Just want to double check the tap stuff so I don't be a complete noob and just break the tap off. It's in here somewhere. Tap. Tapping at 600 RPM, 3 by 0.5. Okay, we should be good. I've run this a few times before, so. All famous last words, they say. Close the doors. Oh, no, there was one thing I wanted to do. I think my face mill's taking off a little bit more than I'd like, and I haven't reset the Z on it for a while. So I'm actually gonna use this offset screen that I was talking about before, work offset, and I'm just gonna leave 0.3 millimeters on the part. From memory, that's what I needed on there. I think it came out a little bit undersized. So I'll just go back to the tool thingo. So next time I need to remember to remove that for making another part, otherwise it's not gonna come out the right size. All right, so back to Program Manager. Op2 execute. And there's a little time counter thing here. I'm gonna say, count the time. And I wanna do 25 runs of these. And I've done 0. Oh, I didn't push input. 25 input. So I kind of like this little counter thinger. And then, gonna hit cycle start. And I'm just gonna play with the feed override, so. Here we go. Roughing end mill. This is where the pucker factor normally comes in. Making chips in the morning. I hope my wife doesn't watch this. Cool, so that's the top hat gone. Aaron Paul's probably going to hate me for this video because I've basically shown you all of the training stuff. Whoops. Cool, so that top hat's gone now. It's just a much safer way of getting rid of it. I really need one of those like shear hog things. I'll probably get rid of it a lot quicker. Just going to face a little bit off now just to clean up that surface finish. Yeah, I know the coolant's not aimed in the right spot, but you can't have it. I mean, I need one of those spider cool things that like flicks coolant in the right spot. So many things I need one day. Spot drill. So this is also chamfering the back of the holes from the first stop. Come around the side. Can't really see. Oh, I can zoom. Cool. Hope the resolution's okay. Drill. Hey, look at that. I measured the tool offset right. And on the soft jaws, I've got reliefs on the backside for the tap to go through, so yeah, tap shouldn't snap off inside the part. Air compressor's running pretty hard. So it's my little chamfering thingo. You're watching a documentary about milling machines. I should change it to this one when I break something. Dun dun dun! Massive pucker factor. Is this a dream? Or real life? Oh, stop playing with that now. So this is the little ball end mill. Just doing that radius that we were talking about before that could be done a lot quicker. That doesn't take too long with this one though. Maybe 30 seconds per radius. It's got a really fine step over too, so I could probably make it a bit rougher. But I'll just leave it. I need that robo drill tool change, man. We would be making chips already. Oh, okay. We're gonna tap pucker factor on 600 RPM. Yeah, baby. I don't know. I need to play with the tapping speeds a bit more. I'm sure I could tap a lot faster. I'd be really interested to know like what RPM people are tapping at. I've only been going up to like 500, 600 RPM, so yeah. I think after these are tapped, it just faces it off and it's done. See how much longer we've got left. Well, it's been running for almost 8 minutes, so. Last one, I think. Yeah, it's got some hair on there. My face when looking. Yeah, light finishing pass. God, this thing is scary, man. It's only just touching it. I think that code thing I put in the end, I got like some error thing. I'll have to figure out what that is. I think it's what I put in there. So N4960. There you go. So it didn't run all smoothly. What I can do now, this is sitting off the end of the part. To stop it, I can just push reset. So N4959. And then I can just jog it up out of the way. So close. I think it was that thing I added in the end. Let's have a look. Let's have a look. Load it up in brackets. N4959. Huh, okay. It's actually that line of code there. So, why? Why you do this? It was on the lead out radius, I think. Sometimes I get like little bugs with these lead ins and lead outs, so I'm just gonna change it all to linear stuff. It's just boof boof. I don't need any of that fancy stuff anyway. So I'll just repost that to the machine. Op2, override it. And that should fix it up. Replace. I'm gonna put my little table to door code in there. It might be because I didn't put an N thing in there. An N number. Anyway. I think I was distracted before I didn't put it in there. 4958 is the next line. Yeah, that'll be what it was. It got stuck on that line because it couldn't read the next one. And then this one needs to be the next number, so. Yep, let's try that. Save it. And then reload it to the machine. I'll do that later. I'll show you guys the part, I suppose. Ooh, it looks good. I like. It's kind of mirror-y. I don't know how you say it. It's probably not even a word. Okay, crack it open. There you go. Oh, you can see us. Can you? Not really. Yeah, so that's the part, and then the last op's just punch a hole through the side. And then we've got to anodize them. So, yeah, anyway, I'm not going to bore you guys anymore with... I've got all of these to crank through. And it did take a little while. That took 8 minutes 51, so, yeah. I got a few parts to do. Anyway, I hope you guys enjoyed seeing that sort of process, like booting up the milling machine, setting the origin, or probing an origin. It's really, it looks like I'm looking away from the, I don't know where the camera is on the phone. And then setting up like tool offsets and stuff. So yeah, it's a pretty long stream. So just skip through all the boring bits. Yeah, and if you guys have any questions or like questions that I missed during the live stream, just put them in the comments box and I'll respond to them as soon as I can. But yeah, right now I need to get cranking on these parts because I had a fair few orders overnight, so yeah. But it's exciting, I like it. I just need to make like a bulk fixture to get this stuff cranked out easier. The struggle is real. All right, catch you guys later. Thanks for tuning in and have a great Sunday or Saturday, wherever you are in the world. Peace out.